Hi everyone. Today we're going to see about how CAN TP protocol works and types of frame in it, how the interaction between the client and the server and the frame and flow. Let's get started. So what we are going to look is about what is CAN TP and how it is works and types of frame like single frame, first frame, consecutive frames and flow control frame. So why we need CAN TP? So normal CAN protocol was able to share not able to share more than 8 bytes. So because of that, so CAN TP protocol will able to share more than 8 bytes over the CAN bus. This is not possible for the normal CAN. So maximum 8 bytes. So if you want more transfer more than 8 bytes, we need to go with CAN TP. So here we can able to send up to 4095 bytes through the CAN bus. So common applications are like UDS, so for flashing the news of or else diagnosing the messages inside the ECUs. So these are the common applications for this CAN TP protocol. So how CAN TP works? So basically the CAN TP will prepend 1 or 2 bytes in the CAN frame as a metadata in before that CAN frame, byte 1, byte 2. So these metadata are the protocol control informations or PCI we used to call. So these PCI decides what type of frame like single frame or first frame or flow control and consecutive frame. So this single frame, like if you have less than 7, so you can go with the single frame. If you have more than 7 till 4095, these first frame and consecutive frame concepts comes into the picture. So as I said, these are types of frame. So how to differentiate these types of frame based on the index? So in CAN frame, byte 1 decides the types of frame. In byte 1, higher nibble if it's all 0, single frame, 1 first frame, and 2 consecutive frame, and 3 flow control. Okay, so first frame, single first, we're going to see about the single frame. So single frame is like if you have the data to be transferred like less than or equal to 7 bytes, you can go with the single frame. So how so we need to start with the index of 0 in byte 1 in higher level. In that lower level, we need to specify the length of the data we are going to transfer. Like 0 to 7 is possible here. So 0 to 7 we need to specify, and the data we need to specify in the remaining CAN frame buffer. So this has an like only less than or 7 bytes is possible here. Okay, first frame. So first frame comes into picture when you have the data more than 7 bytes till 4095. We can use this first frame concept. So how we differentiate? Same as I said, like index. So there is a 0, here it's 1, and we need to specify the length, right? So for the length, we'll take the 12 bits next to the index, like a lower nibble of byte 1 and byte 2. So all 12 bits will indicate the length from 0 to 4095. So here we need to specify length, and the remaining 6 bytes we can start transferring the data between the client and the server. This is a consecutive frame. Consecutive frame comes after the first frame. So first frame will specify the length and the first 6 bytes. So remaining of the 6 bytes we need to send through the consecutive frame. Like till 4095 we need to send here. So it will be differentiated with the index 10 index and sequence number. I'll explain how the sequence number works. And the sequence number incremented from 0 to F, and remaining 7 bytes contains the data to be transferred between the client and server. Okay, I'll explain. Okay, come. So this is a consecutive frame, and this sequence number, as I said, it starts from 1. You need to be very sure it starts from not 0. So it starts from 1 and it will go till F, and then again it starts from 0 and it will go to F, again 0 to F, like till the length what you specified in the first frame. It will keep on going, and the remaining 7 byte is a payload in a sequential order, so it will be clear. Then first flow control frame, flow control. So all these three frames, right, these are coming from uh, client to server, like UDS to ECU. So this is the frame will come from ECU to UDS. I'll show you 1 second. Okay, see. So all this come from UDS to ECU, but this flow control alone come from ECU to UDS. So basically this flow control will specify the number of frame it can accommodate or the speed of the data it can able to process to the diagnostic. So it will tell the diagnostic, hey, slow down so that I can able to process slowly, or else send these number of buffers or number of data buffers only so that I can accommodate that alone. So I'll explain how this is differentiated. Okay, basically this is the frame. So this frame indicates the index. So 0, 1, 2. This is 3, flow control 3. And this is a flag, flow status flag. It will goes from 0 to 2. 0, 1, 2. So 0, 1, 2. 0 is a clear to send. So it will send to the diagnostic or UDS like you can able to send the data. And this wait is 1 is a wait. So wait for my next control buffer until that I process slow. It will send wait 1 as a wait, and we need to wait for another flow control. In another flow control it will send 0, so that till 0 if we get, we need to wait. This 2 indicates like about or overflow. It's if a 2 comes, we need to stop the process or about. So like there may be any issue, can't control the data or the buffer size or exceeded. So this flag indicates when to stop or about the data. Next, this is in lower level of byte 1 flow status, and then byte 2 is a block size. Okay, so block size is basically how much data that ECU can accommodate. It will indicate. So I'll explain how it is. Okay, if the flow status is 0 and the block size is 0, it indicates like clear to send all data. If flow control is 0 and block size is n is a number of bytes, no, sorry, number of frames. So it indicates like just send me these number of frames alone. So after this I can't process like that. It indicates to the UDS server client. And so like this I said, 0 0 means clear to send, 0 n means send just n number of frames from that UDS to the ECU, and remaining all you can ignore. Just we need to focus on these two. And third one is a ST minimum, like a separation time minimum. ST means separation time minimum between the can frame for. So okay, so this STime minimum link we used to send the consecutive frames, right? So it indicates just wait for this number of period of time and then start sending. So that is you can process the data and do the operation. Okay, so that S number of link is 0 to 7F means it's in millisecond. So wait for this step of millisecond and then send a consecutive frame. If the data is F1 to F9 means it is like 0 to 900 microseconds. 0 to 900, 0, 200, 300, 4 till 900 microseconds. You need to wait and send the data. So like this. So that it will wait and send so that ECU can process. So if ECU is not at that much capable of doing the data at fast rate, it will indicate to that UDS like please slow down and then send data like that. So this is a high level of CAN TP protocol. If you have any doubts, just comment it and we can discuss that. Thanks.